Okay, so let us look at these two questions, and they relate to organ plane and complex sets. Question number 11 would look like a straightforward question, and it obviously is a straightforward question. Question number 12 is a little bit tricky, so let's start on question number 11 and see how to go ahead with this. So this here, you are given a point on the organ plane, and that point is Z, and on the same organ plane we are required to mark the point showing complex number iota Z bar. So the point given basically is this, and that is our Z. So first thing we need to find is we want to find iota Z bar. So first we need to find is Z bar. Z bar is a conjugate of Z, so it is a reflection of Z in real axis. So our Z bar would be here. Now when we are multiplying this with iota, so whenever you multiply a complex number with iota, basically you are rotating that vector counterclockwise by an angle of pi over 2. So this point here will be rotated counterclockwise in this direction here, and our point would land here. I'll clean this line up, and this is basically the point that we are looking for. A straightforward question, easy one, simple, doesn't require much thinking. But let's look at question number 12 now, and that question is a little bit tricky. So here what we are looking for is on an organ diagram, we're looking for a set of points which lies on a circle of radius 2. So what this means is that our complex number will always have a length of 2 units. So what if you want to write in Cartesian form, what we are looking for is x square plus y square is equals to 2 square. Yeah, so let's look at the first one. First one is Z bar is equals to 2, which is basically, it can be written in this form, that is equals to 2. And this, what is it telling us? I mean, I can further simplify this. Let me erase this part here. Further simplify this is equals to square root 2. So what we have is, this tells us that the length of the vector on the complex plane is equals to root 2. Whereas here, what we want is the length of the vector on the complex plane is always equals to 2. So this is, of course, this is a circle, but the radius of the circle is only root 2 here, and what we want is the radius of the circle to be 2. So this is not our valid answer here. So let's move on to the next option. Next option is Z square equals to 4. Now we need to remember that this is Z square. This is not mod Z square. So Z square is basically, you have a complex number, then you square it, and when you square it, you get a number equal to 4. So which number would, I mean, if you look at this, there are only 2 numbers which will give you, which when is squared will give you a 4. So these 2 complex numbers are, first one is, I mean from here, first one is 2 plus 0 iota, another one is minus 2 plus 0 iota. So this set of complex numbers has only 2 points, and these points do not lie on a circle. These 2 points lie on the real axis and on the either side of your origin. So this also is not a valid option. Let's look at part C. Part C here again, it says that real part of Z square and imaginary part of Z square equals to 4. Now again, Z square, it is not Z, it's not mod Z, square of mod Z, it is square of the complex number itself. So when you look at it, you will feel that you should be able to see that you're squaring a number, you are squaring a complex number, then you're taking the real part and you're taking the imaginary part and you add them, and that equals 4. obviously you should feel that it wouldn't give you a circle. We can check that algebraically as well. So if our complex number z is equals to x plus iota y, then I get the z square is equals to x square plus iota y square plus 2xy iota, and that gives you x square minus y square 2xy plus iota. So this, the set definition here, it says z is a complex number and such that real part of z square and imaginary part of z square add to 4. So this is my real part here, that's my imaginary part, I add them and that should give me a 4. So that the points lying within this set will be given by x square minus y square, that's the real part, plus imaginary part, and that is equals to 4. Obviously it is not a circle, in fact it is a hyperbola. So a circle, you would have x square plus y square, and then you don't have, in a circle you don't have product terms, you should have ax and by here. You cannot have x and y together, so this is not a circle. So again, option C is not a valid option either. Okay, let's look at the option number D. Option number D is giving you z plus z bar square. So here z plus, when you add a complex number with its conjugate, that gives you pure real numbers, real part, basically 2 times the real part, and this will give you 2 times the imaginary part, but with the iota as well. So I think it would be better if we work on this expression. So this complex number here, if my z equals to x plus iota y, this set definition here would give me x plus iota y plus x minus iota y, that's my z plus z bar square, minus here, I think I can clean this thing up, I don't need this thing here. So, and x plus iota y minus x minus iota y square equals to 16, and we can further process it. That gives you 2x whole square minus 2 iota y whole square equals to 16. That gives you, let me scroll it a little bit down, and you can see here this is 4x square, and this is minus 4 iota square y square equals to 16, and that gives you 4x square plus 4y square equals to 16, which gives you x square plus y square equals to 4. And we can see here that this basically is the equation of a circle, x square plus y square equals to 2 square. This is a circle and the radius of the circle is 2. Basically this is what we are looking for here. We are looking for all the complex numbers in the set lying on a circle of radius 2. That's what we have here. So D is your correct option. But while we are here, let's also take a look at option E and see where we get up to. So I'll leave this thing here and I'll work on E. So E says that real part of z square plus imaginary part of z square is equals to 16. So if I use z as, if I say z equals to x plus iota y, then this definition of the set gives me the real part of z square, so x square, imaginary part of g square, y square is equals to 16. So again it gives a circle, but you can see that this circle has got a radius of, this gives you radius of 2, where radius of 4, and therefore this is not the correct answer. The correct answer is D.